start with the first situation where you have two blocks like this and you are pulling this block. So you are applying some external force on the second block. Okay, we call this block 1. This is block 2. Okay. So first let's look at block 2. When I'm pulling block 2, I try to make it move to this direction, right? So there must be some frictional force acted on this block to prevent this tendency. Okay? That frictional force is provided by the ground. So there is some frictional force to this direction, right? And at the same time, look at, so when you try to pull this object to this direction, relative to this object, object 2 is trying to move to the right, relative to the object 1, right? So the object 1 will also try to prevent this tendency, just like the ground try to prevent this tendency. So the object 1 will also apply some frictional force to object 2 along this direction. Okay? Is there any question here for the frictional force acted on the object 2? Okay. But now, think about the frictional force acted on the object 1. Does object 1 has any frictional force?
Yes.
Which direction?
To the right.
Okay. Okay, sorry. I made a mistake here because it's not moving. Okay, because it's not moving, so you don't have the frictional force for the upper object. Okay. Now, what I'm trying to say is like this. So this is no motion. Okay. So you have some frictional force to object 2 acted like this. There is no force acted on 1. So 1 doesn't provide any force to this. Okay, now, if I apply some force and we can move the 2, we can make the 2 move together. Okay? So I'm pushing the 2 move together to this direction with some acceleration. Okay? Question?
So the weight from block 1 isn't putting any force on pushing it?
The weight on block 1 did provide some normal force to it, but that's not frictional force. You have normal force, but you don't have friction, because now they're connected together, both ends stay at rest, okay? And there is no relative tendency for the motion. But okay, let's consider this case. Now, the 2 are moving together, okay, with some acceleration. Now, in this case, since they are moving, then you still have some frictional force from the ground acted on the object 2. Now, of course, in this case, it's Fk, right? Okay. So the value may be different, but there's nothing difficult to think about. And now, if you consider the interaction between the two objects, then in this case, there is a frictional force Fs acting on object 2 from object 1. And object 1 will feel some frictional force Fs to this direction. Okay? And the reason is that if you make it accelerate, so now this object has a tendency to leave this object behind, right? If you accelerate the object 2, so it has a tendency to leave the object 1 behind. But since this is a rough surface, so the first object will try to pull the second object back. So it will give some frictional force to the object 2. But if the external pulley is not very large, so this one cannot prevent the motion, and this one, object 1, will move together with the second object. Okay. And in this case, the second object will provide some static frictional force to object 1, but in the forward direction. Can you see that? And the reason is that this is the reaction for this force. So it's opposite to that. Okay? In other words, the object 2 has a tendency to move backwards. See, from object 1 has a tendency to moving backwards compared with object 2. Okay. Another way to try to understand this situation is that this frictional force is the force to provide the acceleration to that reaction, right? Because you don't have any other force can provide the acceleration for this object. Okay? So this is the more complicated situation if you start to make it move. Try to think about this, and so you have a better understanding for the static